morning, all of you. I am Mahima Saxena, Assistant Professor at Akgec in CSE Department. Today, this is my third video lecture on DBMS, and today I'm gonna present on checkpoints. For understanding checkpoints, we need to understand first of all what is transaction. Basically, any logical work or set of works that are done on the data of a database is known as transaction. Logical work can be inserting a new values in the current database, deleting existing values, or updating the current values in the database. For example, adding a new member to the database of a team is a transaction. Basically, to complete a transaction, we have to follow some steps which make a transaction successful. For example, we withdraw the cash from ATM is an example of transaction, and it can be done in the following steps. Initialization, if transaction, inserting the ATM card into the machine, choosing the language, choosing the account type, entering the cash amount, entering the PIN, collecting the cash, aborting the transaction. Basically, whatever we are performing to complete a operation is called a transaction. If I need to withdraw some amount from my ATM card, then the amount we perform some inserting an analysis and choosing the amount. Basically, these are the operations we need to complete the transaction. We have 3 steps in the DBMS for a transaction, which are as follows: read data, write data, and commit data. First of all, what is the read data? In the read phase, the only operation is performed that we only read the data. We do not perform any changes in that particular data. But in write operation, we perform the changes. After that, commit is the operation when the updation is done, commit is performed, and after commit, the values are changed in the main database. These are the 3 operations which is very important for any transaction, for any database. We can understand this by some example. Let's suppose we have 2 accounts, account 1 and account 2, with initial amount like something 1000 rupees. If we want to transfer 500 from one account to another, suppose one to another, then we will commit the transaction. All the account details are in secondary memory so that they will be brought into a primary memory for the transaction. Now we will read the data of account 1 and deduct the rupees 500 from that account 1. Now the account 1 contains rupees 500. Now we again read the data of the account 2 and add 500 to it. Now account 2 will have 1500. In the end, we will use the commit command, which indicates that the transaction has been successful, and we can store the changes in secondary memory. If any case there is a failure before the commit command, then the system will be back to its previous state, basically to its initial state, and no changes will be there. This is called a transaction. Now, next topic is failure classification. What if the transaction is failed? Then what are the conditions? To find out what the problems has occurred, we generalized a failure into the following categories. Number first is transaction failure, system crash, disk failure. Now what is transaction failure? Transaction failure is basically when a transaction is failed because of any XYZ reasons, but the transaction is failed. Then this failure is called transaction failure. Basically, the transaction failure occurs when it fails to execute or when it reaches a point from where it can't go any further. Basically, if we have a few transactions or a process is hurt, then it is called a transaction failure. Suppose suppose we have in previous example, we have 2 accounts, account 1 and account 2. In account 1, we transfer some amount from account 1 to account 2. If any I given the wrong command, or basically some system failure occur or some connection failure occurs, the transaction is not completed its intended purpose. That's it. That is called transaction failure. Now, reason, basically, what is the reason, particular reason for transaction to be failed? Logical errors, syntax errors. Now, what is logical error and what is syntax errors? Logical error is basically if transactions cannot complete due to some code error or an internal condition, then the logical error occurs. If, I'll repeat my words, what is a logical error? If a transactions cannot complete due to some code error or an internal error condition, then the logical error occurs. The next one is syntax error. You all know what is the syntax. It occurs when the DBMS itself terminates an active transactions because the database system is not available to execute it. For example, the system abort an active transaction in case of deadlock or resource unavailable. Now, what is deadlock or resource availability conditions? Deadlock is a condition where, suppose we have 3 transactions and some data item is held by suppose a data item A is held by transaction T1 and the data item B is held by transaction T2 and the data item C is held by a transaction T3. Now, T2 transactions require data item A, but A is already held by T1 and here the transaction is not ready to release that data item. Because of that, deadlock occurs because T1 is holding T1 transaction is holding data item A and T2 transaction is holding data item B. T2 transactions require the data item A and T3 transaction require data item B and T2 transaction require data item C. Because of this, all the condition, no transaction is ready to lose that particular data item, but they also want to acquire the next data item. This condition, this whole complete condition is called as deadlock or resource unavailability, when the resource is not available for transaction to capture it or to log it. Now, the second one is system failure. As we all know, what is system failure? System failure can occur due to the power failure or any other hardware or software failure. Example, operating system error. Next one is fail stop assumption. In the system crash, non-volatile storage is assumed not to be corrupted. The next one is disk failure. Now, what is disk failure? It occurs when hard disk drive or storage device used to fail frequently. It was a very common problem in the early days of technology evolution. Right now, it's not like a daily based problem, but yeah, it is a problem. We can consider it in a problem phase. Now, the next one is disk failure. Disk failure occurs due to the formation of bad sectors, disk head, crash, and unreadability to the disk or any other failure which destroy all or parts of disk storage. The next one is log based recovery. Now, after that, the failure occurs, and because of that failure, we need to recover them. So we have some points from where we recovered our transactions, or we try to recover our system or database system, etc. Now, what is log based recovery? The log is a sequence of records. Log is basically a sequence of records. Log of each transaction is maintained in some stable storage so that if any failure can occur, then it can be removed from there. Basically, log all the operations we are performing, we are stored in a diary. Suppose we have a diary and we all the operations we are performing, we stored in a diary. And if some failure occurs, basically all the operations are performed on that copy of particular database. And if any failure occurs, then we will remove that copy of that database. If not, then we will link it from original one. If any operation is performed on the database, then it will be recorded in the log. Any updation, any operations, updation, deletion, insertion, alteration, all the operations are performed on the database, and after that record in the log based diary. But the process of storing the log should be done before the actual transaction is applied to the database. When the transaction is initiated, then it writes start transaction name. Basically in brackets we type that transaction name and then start. When the transaction modifies the city, suppose we have an example, and I need to modify a city from Noida to Bangalore, then it can be written as transaction name city Noida to Bangalore. When the transaction is finished, then it writes another log to indicate the end of the transaction. Basically, after we perform all the operations, we will write commit. That means the transaction, all the updations are done, and all the updations also after the commit operations, all the updations are done in the database. Before that, if suppose we have two transactions, one transaction is committed and the other transaction is not committed, after the commit operation, the updation should be made in the database. But in the T2 transaction, before the commit operations, the transaction failed, then the transaction will remains at the previous stage from where all the operations are started, from where that particular transaction that is failed, from where that transaction is before the starting the transaction. This is the role of commit. Now the next one is, there are two types of log-based recovery, basically two methods of log-based recovery. First one is immediate database modifications, and the second one is deferred database modifications. Now, what is deferred and immediate? In deferred modification, techniques occurs if the transaction does not modify the database until it has committed. In this method, all the records are created and sorted in the stable storage, and the database is updated when a transaction commits. Second one is immediate database modifications. The immediate modification techniques occur if database modification occurs while the transaction is still active. In this technique, database is modified immediately after every operations. It follows an actual database modification. Basically, in deferred database, when the commit operation is performed, all the updations is made after the commit operations. But in immediate database modification, whenever the operation is performed, the updation is done automatically. Side by side, updation is also done. Basically, updation is done simultaneously. The next one is recovery using log records. When the system is crashed, then the system consults the log to find which transaction need to be undone and which need to be redone. If the log contains the record TI start and TI commits or TI commits, then the transaction TI needs to be redone. If log records TN starts but does not contain the record either TI commits or TI abort, then the transaction TI needs to be undone. Suppose we have a transaction T1, it starts and after some time it ends. Basically, it commits. We have both of the operations T1 and T1 starts at this particular time and T2 and T1 commits at this particular time. Then after this, we don't need to undo this transaction because we have T1 start and T1 commits operation. But if transaction T1 starts and never commits, we don't have the operation commit, then we must undo that particular transaction. This is the basic difference. Now the next point is checkpoint. Now what is checkpoint? Checkpoint is a type of mechanism where all the previous logs are removed, from the system and permanently stored in the storage disk. The checkpoint is like a bookmark. While the execution of the transaction, such checkpoints are marked and the transaction is executed. Then using the steps of the transactions, the log file will be created. When it reaches to the checkpoint, the transaction will be updated into the database, and till that point the entire file log will be removed from the file. Then the log file is updated with the new step of transaction till next checkpoint, and so on. The checkpoint is used to declare a point before which the DBMS was in the consistent state and all the transactions were committed. recovery from checkpoints. Suppose we have checkpoint and we have failures. I will explain this in this particular type of scenario. The recovery system read log file from end to start. It reads file from basically T4 to T1. This is the example, and the recovery starts from reading the file from T4 to T1. Recovery system maintains two lists, a redo list and a undo list. The transaction is put into the redo state if the recovery system sees a log with tn start and t1 commit, or just tn commit. Basically, in the redo list and their previous list, all the transactions are commit or just tn commit. In the redo list and their previous list, the transactions are removed and then written from before saving their logs. For example, in the log file, transaction T2 and T3 will have tn start and tn commit. The transaction T1, basically in transaction T2 and T3, we have start and commit operations in the log file. That's why the transaction is committed after the checkpoint is crossed. Hence, it puts T1, T2 and T3 transactions into redo list. The transaction is put into undo state if the recovery system sees a log with tn start but no commit or abort log found. In the undo list, all the transactions are undone and their logs are removed. For example, transaction T4 will have tn start, so T4 will be put into undo list since this transaction is not completed and failure emit. Basically, we have two lists. In checkpoints, we have two lists, undo list and redo list. If any transaction has start point and commit point, then it will be put it into the redo list. If they have not, if the transaction has not T2 and if the transaction had not start and commit points, then it will be put into undo list. This is the basic example. Now, what is deadlock in DBMS? A deadlock is a condition where two or more transactions are waiting indefinitely for one another to give up logs. Okay. Basically, I have previously explained what is deadlock, but in detail I'll explain here. Deadlock is said to be one of the most feared complications in DBMS. Or no task ever get finished and it is waiting in the waiting state forever. For example, suppose हमारे पास तीन ट्रांजेक्शन्स हैं, T1, T2 और T3. T1 ट्रांजेक्शन के पास एक डेटा आइटम A है, T1 ट्रांजेक्शन के पास एक पेंसिल है, T2 ट्रांजेक्शन के पास एक इरेजर है और T3 ट्रांजेक्शन के पास एक शार्पनर है. अब T1 को आपकी इरेजर और शार्पनर, इरेजर चाहिए और पेंसिल उसके पास खुद है, बट वो उस पेंसिल को लूज नहीं करना चाहता और उसके बाद उसे इरेजर चाहिए. जो T2 ट्रांजेक्शन है उसके पास ऑलरेडी इरेजर है लेकिन उसे शार्पनर और पेंसिल दोनों चाहिए. वो भी उसको लीव नहीं करना चाहता, बिना दिए उसको बेसिकली वो नहीं लेना चाहता. T3 के साथ T3 ट्रांजेक्शन के पास एक शार्पनर है, उसको पेंसिल और रबड़ दोनों चाहिए. अब इस वाली सिचुएशन को हम कहते हैं डेडलॉक, जहां पे एक ट्रांजेक्शन ने एक आइटम को होल्ड कर रखा है लेकिन वो दूसरे आइटम को भी, उसको दूसरे आइटम की भी जरूरत है और वो उस आइटम को उस आइटम को रिलीज नहीं करना चाहती है, दूसरे पे होल्ड करना चाहती है. इस पूरे प्रोसेस को डेडलॉक कहते हैं. इस पूरे प्रोसेस में जब भी डेडलॉक में कोई ट्रांजेक्शन हमेशा इसी स्टेट में रह जाती है क्योंकि कोई भी ट्रांजेक्शन रिलीज नहीं करना चाहती और नए आइटम्स को एक्वायर करना चाहती है. फॉर एग्जाम्पल, in the student table, this is another example. Transaction T1 holds a log on some rows and needs to update some rows in the grade table. Simultaneously, transaction T2 holds logs on some row in the grade table and needs to be update the row in the student table held by transaction T1. Now, the main problem arises that transaction T1 is waiting for T1 to release its log, and simultaneously T2 is waiting for T1 to release its log. All activities come to a halt state and remain at a standstill. It will remain in a standstill until the DBMS deduct the deadlock and abort one of the transactions. Now, what is, अब deadlock अगर हुआ है तो उसको avoidance के लिए भी तो कुछ चाहिए ही ना. That's why we study deadlock avoidance. When a database is stuck in a deadlock state, then it is better to avoid the database rather than aborting or restarting the database. This is a completely waste of time and resources. A deadlock avoidance mechanism is used to deduct any deadlock situation in advance, a method like wait for graph is used for deducting the deadlock situation, but this method is suitable only for the smaller database. For the larger database, deadlock prevention method can be used. Okay. Now the other is deadlock detection. In a database, when a transaction waits indefinitely to obtain the lock, then the DBMS should deduct whether the transaction is involved in a deadlock or not. The lock manager maintains a wait for the graph to deduct the deadlock cycle in the database. Now, what is wait for graph? This is the suitable method for deadlock deduction. In this method, a graph is created based on the transaction and their lock. It is if the created graph has a cycle or closed loop, then there is a deadlock, otherwise not. The wait for the graph is maintained by the system for every transaction which is waiting for some data held by the others. The system keeps checking the graph if there is any cycle in the graph.